Chemical analysis techniques for environmental monitoring. Chemical analysis techniques are commonly used in the field of environmental monitoring. These techniques are essential for detecting and identifying contaminants that may pose risks to human health and the environment. With the increase in industrial activity and human population, environmental monitoring has become increasingly important. In this article, we will discuss some of the most commonly used chemical analysis techniques for environmental monitoring. 1. Gas chromatography mass spectrometry, GCMS. Gas chromatography mass spectrometry, GCMS, is a powerful analytical technique that is used to identify and quantify volatile organic compounds, VOCs, in water, soil, and air. This technique involves separating the different components of a sample using gas chromatography and then detecting each component using a mass spectrometer. 2. Inductively coupled plasma mass spectrometry, ICP-MS. Inductively coupled plasma mass spectrometry, ICP-MS, is a technique used to detect and quantify metals and trace elements in a wide range of environmental samples. ICP-MS is ideal for analyzing metals due to its sensitivity, and it is used to determine the presence of metals released into the environment through human activities. For example, the analysis of soil samples can provide important information about contaminants that may have been released due to industrial activities, waste disposal, or other causes. 3. High-performance liquid chromatography, HPLC. High-performance liquid chromatography, HPLC, is a technique that can identify and quantify a wide range of chemicals in a sample. HPLC is often used to separate and detect pesticides, herbicides, and other environmental contaminants in water, soil, and air samples. This technique involves passing a sample through a column of a chromatography medium and detecting the individual chemicals based on their retention times. 4. Atomic absorption spectroscopy, AS. Atomic absorption spectroscopy, AS, is a robust analytical technique used to detect the presence of metals such as lead, arsenic, and cadmium in environmental samples. AS works by exposing a sample to light of a specific wavelength that is absorbed by the atoms in the sample, and then detecting how much light is absorbed. This technique is frequently used in environmental monitoring to detect heavy metal contamination in soil and water samples. 5. Fourier transform infrared spectroscopy, FIR. Fourier transform infrared spectroscopy, FIR, is a technique used to analyze organic compounds in environmental samples. FIR works by exposing a sample to infrared radiation and then collecting the amount of infrared light that is absorbed. By analyzing the pattern of absorption, the technique can identify and quantify the different organic compounds present in the sample. FIR is frequently used to detect organic pollutants in water, soil, and air samples. 6. Ultraviolet visible spectroscopy, UV-vis. Ultraviolet visible spectroscopy, UV-vis, is a technique used to detect and measure the amount of certain chemicals in environmental samples. UV-vis works by exposing a sample to UV or visible light and measuring how much light is absorbed. This technique is frequently used to detect contaminants such as benzene, toluene, and other chemicals in water and soil samples. 7. X-ray fluorescence, XRF. X-ray fluorescence, XRF, is a powerful technique used to identify and quantify the different elements present in a sample. XRF works by exposing the sample to X-rays and detecting how much energy is emitted by the sample. XRF is frequently used to detect heavy metals in soil and water samples, and can provide useful information for regulating hazardous waste disposal sites. Environmental monitoring is a broad field that spans the entire planet. It includes the study of air quality, water quality, land quality, and the overall biodiversity of ecosystems. The measurement of these parameters can yield important insights into the health of the environment and how it might be changing over time. For example, increasing levels of carbon dioxide in the atmosphere are causing global warming, which is resulting in rising sea levels and a more frequent occurrence of extreme weather events. Accurate and reliable chemical analysis techniques are therefore essential to accurately monitoring and detecting these changes. In addition to the techniques mentioned above, there are numerous other chemical analysis techniques used in environmental monitoring. For example, gas chromatography electron capture detection (GCECT) is a highly sensitive technique used to detect halogenated organic compounds that pose a risk to human health and the environment. Mass spectrometry (MS) can also be used to detect VOX in the air that might be harmful to human health. One of the most significant challenges in environmental monitoring is ensuring that the data produced by these analytical techniques is accurate and reliable. Environmental samples are often complex mixtures of different chemicals, and it can be challenging to identify and quantify each individual constituent accurately. There can also be interferences from other compounds in the samples, leading to inaccurate results. To ensure the accuracy and reliability of environmental monitoring data, quality control measures are essential. Ultimately, the goal of environmental monitoring is to gain a better understanding of the complex interactions between human activities and the environment. By accurately measuring and characterizing the chemical properties of environmental samples, we can take steps to protect and preserve the environment and promote a sustainable future for all. The development of increasingly sensitive and selective analytical techniques is likely to play a critical role in driving further progress in environmental monitoring. For example, advances in mass spectrometry technology have enabled the detection of trace amounts of chemicals in environmental samples. In addition to their scientific and technological advancements, chemical analysis techniques are often linked to regulatory requirements. The Environmental Protection Agency, EPA, for example, requires the use of specific analytical methods for the detection of various contaminants in environmental samples. The importance of environmental monitoring and chemical analysis techniques cannot be overstated. The consequences of exposure to hazardous substances in the environment can be severe, ranging from acute and chronic health effects to long-term environmental damage. The use of accurate and reliable analytical techniques is essential for detecting and monitoring the levels of these substances and developing mitigation strategies. Beyond its scientific and regulatory applications, environmental monitoring can also serve broader societal goals, such as protecting public health and promoting environmental sustainability. With the increasing importance of environmental monitoring, the use of chemical analysis techniques is becoming more widespread. As we move forward, it is critical to appreciate the value and the limitations of these chemical analysis techniques. Although chemical analysis is an essential tool for identifying and analyzing various contaminants in the environment, it is important to recognize that it is not a magic bullet. Moreover, there are limitations to these methods and it does not always provide a complete picture of environmental health. For example, some pollutants might escape detection entirely due to limitations without testing for every possible chemical or element, or simply not found in the area of the sample. Furthermore, the effects of pollutants on ecosystems may be more profound and long-lasting than the results of chemical analysis can indicate. Nevertheless, it must be acknowledged that chemical analysis plays a central role in environmental monitoring and management.